It's so nice to see everybody here, and we're dedicating our mornings to connecting with our community and discussing compute efficiency, one of the most important topics in our sphere. I'm Allyson Klein. I'm the principal of TechArena. If you haven't started following us yet, we share stories about technology, innovation, and the innovators that imagine it. And we just published our 2024 Compute Efficiency Report, featuring input from the Open Compute Project Foundation, as well as industry and provider leaders, including Airbus, AMD, Ampere, Ayar Labs, Alphawave Semi, Cerebras, Cloudflare, Cornelius, Flex, Iceotope, Intel, MIPS, OVH Cloud, Pacific Northwest National Lab, Phoenix Snap, Schneider Electric, Vast Data, Weka, Zinc 5, and especially our underwriting sponsor, Solidigm. So you know what I've been doing for the last few months. I've been talking to folks about compute efficiency, sustainability, and all of the topics associated with this grand challenge. About a decade ago, a friend of mine, Jonathan Kumi, taught me while he was studying data center power consumption at the Department of Energy that the compute sector was unique in that its contributions to making the world more efficient far outweighed the energy consumption of its infrastructure. And I think that still holds true today, but we're at a really interesting time where we see forecasts of energy consumption and resource utilization of tech growing with staggering forecasts at a time when our headlines are sending continuous reminders of the impacts of climate change to our planet. An example over the last couple of weeks is the hurricanes that are rolling out over the East Coast and changing weather patterns like things that we've never seen before. But at the same time, AI is a force that we've also never seen. We see headlines where arguably the first Nobel Prize enabled by AI was awarded last week to DeepMind's win for the protein folding project that they drove. And if you haven't followed the work that DeepMind is doing in that space, I think that their discoveries will usher in advancements across the medical sector for years to come. And that is just the tip of the iceberg about the technology that we're unleashing together. I think that the way to look at this is that we're collectively very fortunate to have a unique opportunity to carve a path and a responsibility to drive innovation across everything we deliver, to unleash the opportunity of AI across every sector in business and society. And this panel is going to explore what that's going to take in terms of delivering it with the efficiency that it demands. So let me stop talking and introduce you to the experts we've assembled. They're really impressive collectively. I'm going to start with Kelley Mullick. She's Vice President of Technology Advancement and Alliances at Iceotope. She has a PhD in chemistry, and if I get her talking about dielectrics, you're going to really start seeing this panel light up. Jenna Boller, Vice President of Marketing at Ocient. She is known for driving leading marketing strategies and initiatives, and she's driven programs to launch the company's energy efficiency capabilities, and I can't wait to hear about what she's going to be talking about. Roger Corell, Senior Director of AI and Leadership Marketing at Solidigm. Roger and I have known each other for a long time. He's been in the tech industry for quite a long time, over 30 years of experience. A little known fact about Roger is that he's a cyclist. And Solidigm's got this bike that actually powers in their booth, and Roger was the only guy that hit over 300 watts yesterday. So I think the conclusion of this panel is going to be that Roger is going to solve the energy efficiency crisis for us. And then Wendell, Wenjen, Director of Storage Market Development at Supermicro. I talked to Wendell at Solidigm's reception last night, and he's pumped to talk about how his solutions are propelling AI and also delivering efficiency to customers. If you haven't been paying attention to Supermicro for a long time, they've been leaders around efficient IT, and I'm so glad that they're on the panel. And as a reminder, TechArena is delivering an exciting raffle at the end of the panel, so stick around for that. But let's get to the panel. At the end of the panel, if we have time, we'll also open it up for questions from the audience. So think about what questions you might want to ask for these folks. Question number 1, and we're going to start with Wendell on this one. Depending on what study you use, data center power is expanding at an exponential rate, reaching up to 20% of the world's power in some forecasts. I want to start with a foundational question on the changes required to compute infrastructure to fuel AI and where we are as an industry to drive this foundational compute. Are we on the right trajectory to drive the compute required for AI, and is that trajectory keeping efficiency in mind?
I think we're on the trajectory to deliver the compute, but I think the energy required is really another question. So you've asked me to sort of set this up with a number of facts and figures that kind of describe the situation that we're in and kind of the direction that we're headed into. So I kind of look at it sort of like from an economic standpoint, in that there's supply and demand of power, of electricity. So on the supply side, the supply, has been relatively flat the last few years. In the US, it's around 1,200 gigawatts of generating capacity, just increasing, 1 or 2% a year. And that's really due to that fact that everybody's been so great at conserving electricity with Energy Star appliances and changing, using LED bulbs and so forth. And so that's really been fantastic. But on the utilization side, data centers are now using about 2% of the world's power generation. That's really equivalent to the generating capacity of the country of Netherlands. And then, as Allyson mentioned, in the next 5 years through the end of the decade, there's forecasts that it can double to 4%. It could triple to 8%. There was even a report I heard last night from Bloomberg Intelligence that it could go up to 17%. Now, 8% is the total generating capacity of the country of Japan. And really, this is not, I think, at all sustainable for the planet. The cause of this really is that AI and using AI really it takes about 10 times the power of say, compared to ChatGPT, just a Google query. So that's index-based. So it really is a lot more energy intensive to deliver those results. And we're really seeing it in terms of the number of GPUs that are shipped. I think ChatGPT 3 utilized 30,000 GPUs, which are have really increased in power utilization. TDP is the latest one. Blackwell's over 1,000 watts and can only be liquid cooled. And so it's kind of the old metrics that we had in the data center, which had in the enterprise 10, 15 kilowatt racks. Now in order to meet this demand, we're talking about 50, 100, even over 100 kilowatts. Certainly not really doable in the enterprise, and only some data centers can really accommodate that. I had the opportunity last week to have dinner and sit next to a person who ran sales for one of our customers, a data center operator called Scalable, that has 30 data centers. And he said his biggest problem is really getting the power that they need for their data centers. And if you just look in, say, Northern California, there's a need for 6.5 gigawatts of additional power generating capacity just for data centers. And that's estimated at a cost somewhere between $500 million and $1.8 billion of CapEx spending. And that's, our utility here is mainly PG&E. So generating all this additional capacity to run all of the compute required is going to be a really big burden, notwithstanding that there's 1 or 2 companies that, like Microsoft, are turning to nuclear power with the sort of Constellation Energy deal to restart 3 Mile Island. That's really not a sustainable and repeatable kind of thing. So I think overall, on the supply side, it's very challenged, and on demand side, it's just growing very large. And I think we can talk about some of the ways that none of us really are on the power generating side. We're on the power using side, but we can talk about how we can kind of mitigate that and what the path is for that going forward.
It took us 4 minutes to bring up the 3 Mile Island acquisition, which is impressive. Does anybody want to add anything to that?
I think Wendell set the problem up right. I mean, it's a basic economic challenge of supply-demand. How do you bring that into balance? And I think we'll get into it. I think Wendell's done a really good job on the supply side. On the demand side, it's everybody, and reasonably, it's understandable why everyone talks about how much power compute requires, but I think storage needs to be. I represent storage, but I think the discussion of storage needs to be brought into it as well, because AI workloads are extremely, extremely data intensive. So they need a vast amount of storage. So I think we'll talk about that a bit later. So yeah, I think he set up the problem well.
All right, let's keep going then. We'll start with Jenna on the next one. Efficient management of data requires new approaches for data collection, cleaning, training, fine-tuning, and inference. How can we keep an efficiency-centric mindset to grappling with data as enterprises start to integrate AI into applications?
Great question. Thank you, Allyson. So if you're not familiar with Ocient, let me just first kind of introduce Ocient to everyone. So we are a data analytics software solutions provider, and we specialize in providing always-on, very compute-intensive analysis of large and complex data sets in a way that really optimizes for performance, cost, and energy efficiency. So to your point, energy efficiency is kind of at the core of what we do, and just efficiency overall of resource utilization. We actually just launched our own study called the Beyond Big Data Report. It's our 3rd annual study of 500 IT and data leaders around the country, and for the first time ever, we saw 53% of our respondents cite energy consumption and energy efficiency as a top concern, like a top 3, top 5 concern. And that was pretty incredible. We haven't seen the buying side, or I hadn't seen that through our research, rise to such a high level and a high top concern. And 31% said that they would be willing to switch to a new data or AI solution if they could receive an energy efficiency benefit. So I think it's top of mind on the buyer side, but what I think we're lacking, at least within the software layer, is more transparency around the energy cost of what we're doing on a day-to-day basis. Without transparency, it's hard for a user or a buyer to gain control over what they're doing and then make optimizations or govern sort of the energy requirements of their compute-intensive workloads. So at Ocient, this is one of the things we're pioneering. We've had a lot of advanced inventing sessions around low-hanging fruit, how we can help our customers understand what the energy implications are of what they're doing, and then develop new features and functionality so that they can kind of optimize the usage and the timing of their workloads to meet any energy requirements. So I think, to answer your question, in order for people to keep it top of mind and do something about it among the software layer, there needs to be more transparency around how much your Google search is using every time you're doing that, and then you can have the choice to maybe do a different type of, instead of a Gemini query, maybe a different type of query. So,
Roger, with that data pipeline in mind, one of the things that I hear a lot about is that folks are targeting storage to free up energy to make room for all of the compute that Wendell just talked about. How are you seeing this as you're providing the foundational storage for these storage arrays? How are you seeing this rolling out, and how do you see the opportunity for customers?
I'll answer that, but first I want to brag on Jenna and her company a little bit, because I'm surprised. This sounds like a debate here. So I think Ocient is a company that's doing it right. They're looking at it from kind of a total solution stack perspective. They do amazing things in their software. They use some of the industry's most power efficient hardware, including our QLC drives, and they're seeing successes of reducing energy consumption for similar sized data sets of 50 to 90%. So I think that's amazing. And I guess that kind of sort of gives me a transition to talk about storage a little bit more. So yeah, from our perspective, one of the things that we look at is we look at how much network attached storage goes with, let's say, a fully populated DGX rack. So 4, let's say, H100 servers in a rack. How much network attached storage is paired with that? And if you go back, I think it was Llama 3, if you go back just a couple of years, or maybe even just a year, Llama 3 had about 1.5 petabytes of network attached storage with each DGX, 4 by DGX H100 rack. Fast forward to today, we have a design in with a company that is developing their own large language model, 3.5 petabytes of network attached storage. Now that's just, text. Text is small. Now, what about if you do video, right? Video is a much larger, each data point is much larger than text. So another customer of ours is building a large video model that pairs almost 16 petabytes of network attached storage with each DGX rack. So you run the math. We've worked with subject matter experts and consultants in the industry, and we've kind of built this model that helps us assess the potential power savings of moving from legacy storage, in this case, let's just say HDDs, to QLC. And we're seeing opportunities for a 4x footprint reduction, 80% power reduction of isolating power. So 80% footprint reduction for power consumed by storage. And then that's just the core data center. We're also seeing this at the edge. And we're seeing massive data growth in the edge driven by, there's regulatory requirements in the UK. UK always seems to be, Europe always seems to be leading this type of thing, where you have to store every inferred result. So regulatory requirements, more complex models, data repatriation, just keeping that stuff local. We have another design, and I spoke about it yesterday in my talk, where we've got 3.5 petabytes of storage for a DGX rack doing edge inference to improve the urban greenbelt environment for hedgehogs that live in London. Apparently hedgehogs are something really big. Pretty cool story. I think it's on our website. But that's just, so I've told you a whole bunch of case studies of petabyte scale network attached going with each DGX rack, and that takes a lot of power. And that's what our QLC drives can be a big part of the equation. It's not going to solve everything, but it can really, really help in developing an overall improvement in infrastructure efficiency.
I run the Supermicro's storage marketing, and I think just and we use, of course, products from Solidigm in a variety of our all flash and hybrid flash products. And of course we have just storage products as well, which are still commonly used. But kind of like looking back out, I mean, there's a pretty standard hierarchy in computer architecture about the memory storage. I don't want to conflate memory and storage, but the memory storage, pyramid that, is pointing at the top, and the latency as you go down to the bottom, where you have your much slower media, your latency goes up, your bandwidth goes down. But I think from a power perspective, all right, everything at the top, each time you go down kind of one layer down, starting at, say, HBM that's integrated onto the GPU module, and has a very small distance to travel because it's a stack of die right next to the GPU die, and then you go to DRAM, and then you go to flash that's local, and you go to flash on a network attached flash array, and then you go to disk. Right, each time you go down one tier down, and you kind of increase your latency by an order of magnitude. You also increase your power by an order of magnitude, right? So basically the power to access storage down at the network attached big arrays, which is a lot of what we sell, is 100 times or more per byte than it is for that same data to be located in the HBM3 memory. But obviously you can't get the capacity that you need in that local storage, right? So that's really a trade-off. And so we do need large storage arrays. We need the most efficient possible large storage arrays with the most efficient media. And just yesterday I launched our new JBOF, so just a bunch of flash, and it's an array that takes up to 36 E3.S SSDs, a capacity of over 2 petabytes. It doesn't have a CPU in it at all, which most of our storage servers have. And so what it uses instead is a DPU, a data processing unit, which is, in our case, it's the NVIDIA Bluefield 3. But it's built around an ASIC. It kind of combines a networking card, a lot of hardware acceleration, a lot of 16 ARM cores, and acceleration for the data path for both networking and storage. So you can accelerate erasure coding, you can accelerate data compression in that. And so I did some calculations getting back to the power point of this. And on the control plane side, excluding all the power consumed by the SSDs, which is the same whether you have a CPU running things or a DPU running things, it's about half, we think. So at the system level, it's about a 10, 15% power reduction. You could do some math on that, 100 systems. And so you save both the power that the unit consumes, right? And you also save the PUE. So that's the power, the PUE is the total power consumed by the data center divided by the power consumed only by the equipment, right? So typically it's about 1.5. The very efficient data centers, it's about 1.05. So 5% of the additional power is running HVAC and lights and things like that. So you can save, assuming like a 1.5 PUE, like about 15 kilowatts over 100 systems, right? Over 100 systems, which is great, but that's like one 8-way GPU cluster. Right. So it does help, and I think everything helps, and just reducing the total amount of power consumed by all our equipment. But it seems like on the compute side, things are mainly going up.
I want to thank you, Wendell. I want to shift back to something that Roger said for a second. He was talking about compute at the edge, and I think that what that brought into mind is something that I've been hearing at the conference, which is how is enterprise going to actually adopt AI, and what does that curve look like? Because I think that's something that's going to be indicative of what it means for infrastructure. We're at the OCP Summit, which is kind of the queen bee of hyperscale. But I'm going to say that the next wave of infrastructure innovation in enterprise, is it going to be similar or is it going to be dissimilar to what we've seen in the hyperscalers? And what does that mean from an energy efficiency standpoint? And I'm going to start with Kelley. Kelley, you've been so patient here, sitting next to me. Start with Kelley on this question. How do you see that?
Yeah, so thanks for the question. And I'm here at the conference representing my company Iceotope, and we manufacture precision liquid cooling solutions, which is a type of solution that uses dielectric fluid, but in a rack-based form factor with targeted delivery to the hottest IT components, and then full thermal recapture of that heat that's generated from the IT within each chassis. So we have solutions that are deployable for the data center and the edge. Mm-hmm. And so one of the trends that we're seeing is a lot of compute at the edge. We were talking a little bit about how there's going to be all these power demands and energy demands, and how are we going to support the growth and the power trends that are needed for AI workloads, and that is the workload of the future. And so one of the things that we think is that there's going to be a lot of deployments at the edge. And so you need compute-intensive infrastructure to support that growth. And so liquid cooling is one of the most effective and efficient ways to reduce energy consumption, but also do it in a sustainable way.
When you think about enterprise adoption, and I'm going to drill down into this because I know that you all talk to enterprises about what they're planning. What trends do you see in terms of the differences in the ways that they're going to be deploying technology? When you think about that data pipeline, how are they looking at utilizing technology to do the fine-tuning of models, training their own models, driving incredible amounts of inference into their applications from data center to edge? How does that differ from what we've got today, team?
Well, I think we're going to see, I think the ecosystem for enterprises to accelerate AI adoption is getting healthier and healthier. We're seeing reference architectures, standard building blocks, initiatives supporting, easing enterprise infrastructure build out. We're seeing a kind of an open source developer community building these pre-trained models for just an infinite number of enterprise use cases, of which I spoke to a couple of them. But I think when it comes to deploying at the enterprise edge, then you have to start talking about locality constraints and challenges. And everything that we've talked to in terms of power, space, other challenges in a core data center becomes even more acute when you're talking about the edge, because now you've got size limitations, space limitations, power limitations. Maybe it's in a less predictable environment. A truck roll can be super costly, so you've got serviceability and reliability concerns that could be, again, elevated above a core data center. And so I think that's where solution level stuff like what comes out of Ocient, I think that's where super efficient cooling, which comes out of Kelley's company, really come into play. And obviously hyperdense storage and efficient storage can help there as well.
One trend that, just to build off of what Roger said, one trend we're seeing too is a lot of our enterprise customers are rethinking their cloud strategy because they're often already meeting constraints for their more compute intensive workloads. They're aggressively deleting data, they're turning off systems, and they're talking to industry analyst firms like Gartner, Forrester, IDC around how do we govern the cost of all of this, and the answer to them is, well, use less. No one said that using more was going to be cheaper. So, I've been in conversations with folks that have literally put some GPUs in a closet in their organization just because they have to get it out of the cloud. It's just running at a high cost, plus, of course, the energy thing. So I think, we'll see customers who want to have maybe more of a hybrid approach, more control over some of their workloads, maybe more of their training data before they put it into a production environment. And that, of course, again, as we see Microsoft, Google, others going towards the nuclear power route, what about everyone else that can't go that route? And also, what is the cost of their applications going to be once they're running a nuclear power plant, right? So Solidigm and Ocient, one of our customers, we demonstrated how we could save them $1.6 million in electricity over 3 years, let alone the reduction of their software, their hardware costs, things like that. So I think this cost pressure is really causing, at least the customers that we talk to rethink, the all-in cloud strategy. They're trying to think about how to be more efficient and mindful, whether that's deploying at the edge, on-prem, maybe a little bit in the cloud, creating a private cloud, things like that.
Jenna, I'm really glad that you brought that up, and I just have a quick comment on that. For those folks who missed Geico's presentation yesterday at the conference, you might want to check it out when OCP publishes all of the sessions. They told a fantastic story about repatriation of all of their cloud resources utilizing OCP technology. And if you also want to check it out, I did an interview with Rebecca Weekly that we're publishing today, who leads that effort at Geico, if you want to see what enterprises are doing with their infrastructure to make it more efficient. Kelley, you had a comment.
Mention that particular keynote, but what I will say also is another trend that we're seeing is modular designs. So customers are trying to use commonality and common building blocks for their workload infrastructures. And so seeing a shift in modular design and modular builds is something that we're also seeing, and it is driven by cost pressures. So, looking at those kinds of technologies as well is also an important trend, I think, that's driving some of these changes.
Now, we've spent a lot of time talking about compute and storage. I want to shift for a second and talk about the topic du jour this week, which is cooling. I don't know if you've walked the expo floor, but there is more cooling than anything else on the floor. And Kelley, can you please kick off this next discussion on why power and cooling are so central to the AI conversation? I think that really became a center of attention. I mean, it was a center of attention at last year's OCP Summit. I think at GTC, Jensen threw the gauntlet on cooling. Tell us where we're at.
Yeah, so it's a great space to be in. We're really at the infancy of where AI workloads are going to take us into the future. So it's a great technology to be in. If you're a technologist, it's exciting. It's one of the most pivotal changes in technology that we've seen in probably the last 40 years. So with liquid cooling, this is a technology that's been around for many years. Cold plate direct-to-chip is the more predominant form of liquid cooling. You'll find several at-scale environments that use direct-to-chip primarily in the HPC or high-performance compute market, which is great. And that's always been kind of considered like a niche area. That's where the people are doing their supercomputers, the top 500. But that's a leading trend of where compute is going. I mean, as my colleagues have shared, all of the IT components are rising in their thermal design power requirements. And AI has just accelerated that significantly, almost a 2x bump, where the leading generation processors are around 400 to 600 watts, and Blackwell is going to just shift that out of the market with 1,200 watts. So we've got to be ready with the compute infrastructure. And with that shift, air is at its limits at around 600 watts for a 2U processor. So we've got to have liquid to support that shift. The liquid is the only medium that can really cool effectively those higher IT components. And so now it's a requirement. It's not a niche market. It's not something that's kind of cool that industry needs to explore. The reason we're seeing so much of it is because it's going to be required to support these workloads. For those who aren't familiar with the Iceotope solution, it is a very unique solution that is differentiated in the market. It is a solution that comes in a traditional rack-based form factor. But each chassis, the IT is actually integrated with the cooling solution. And so we use dielectric fluid, and that dielectric fluid is recirculated within the chassis. And that system or those racks can be interoperable with other advanced cooling solutions in the data center. So you could leverage the same CDU setup for your cold plate solutions with the precision cooled solutions with your air cooling. So it's a really great technology for bridging the gap between different types of cooling solutions, which we see is going to be a trend as companies are retrofitting for liquid.
Thanks so much.
I just add, Supermicro's kind of point of view on cooling. And so we're really big proponents of liquid cooling. We've been working on that for quite a long time. We're also using direct-to-chip liquid cooling, but in a closed loop system where each unit's coolant is really exhausted out to an external cooling tower or heat exchanger, and all the heat is dumped outside of the data center. So you don't really have to. So you can have a much more efficient air conditioning. You can do somewhere between 85% of your heat gain can be dumped outside the data center using liquid cooling. And so we make that complete system from the direct-to-chip cold plates to the CDUs to the two-story cooling towers in the back. And so in our production facility here in San Jose, we have a 5-megawatt cooling tower in the back. It's not even a data center. We just have this, and we're building a second 5-megawatt one right next to it. And that's just for doing the testing. So we're able to run through our production line 5,000 full racks of liquid cooling, and you have to burn it in, of course, do the testing a month. And so that's really, we think, the most capacity of any manufacturer in the industry to deliver that. And and more, a lot of our customers are adopting liquid cooling in their data center, and we really see that adoption going up dramatically, and especially with GPUs like Blackwell. That really requires it. Even some of the latest CPUs we just launched with AMD last Thursday, their high-end 92-core Turin CPU is 500 watts, and you can use liquid cooling in that. So really the difference is that we can do an 8 GPU system with either NVIDIA, Blackwell, or the Hopper, or an AMD Instinct, the latest one that we just launched, the MI325X. We can do 8 of those in an 8U with air cooling. Actually, excluding the Blackwell, which requires liquid cooling. Or we can do 8 of those in a 4U with liquid cooling. So you can really get huge improvements in density using the liquid-cooled technology.
So I've got one final topic before we turn it to the audience, and this one's predictions time. We're coming at the end of the first half of the decade, of the roaring 20s, I would call it. We saw a global pandemic and the birth of Gen AI as the key themes of the first half of this decade. As we head into 2025, what's the central focus for the second, and what is computing's role?
I definitely think sustainability will be a growing theme. It's being a California native, I often think of California history and the gold rush and how folks kind of rushed to find gold everywhere, and then they realized, oh, we're like blowing up mountains and we're destroying the environment. And so then, there was kind of like a way to do gold mining more responsibly, or kind of this swing back to maybe we can't just kind of follow the gold, and we have to kind of realize the impact of what we're doing. So that's my hope, at least as a resident of the planet, that sustainable IT solutions will grow. Thank goodness for all the work that you are doing at your companies to provide more solutions to the market. Like I said earlier, I think the software layer needs to also follow suit and look at ways to be more efficient. And not just do more because we can do more, but to find ways to do so sustainably and to help our organizations meet their carbon net zero goals, things like that, so that we can continue innovation, not stifle innovation by running out of energy, and to continue to build responsible solutions.
So I agree with Jenna, and I'm hopeful that sustainability is a key theme moving forward. I mean, the AI train has left the station. It's inevitable, right? The build-out's going to continue, if not accelerate. I think when we just talk about AI, to me, the first half of this decade is characterized by, let's just say, kind of hyperscalers building these big core models. I think the second half of this decade is going to be more about an enterprise edge focus. And I think Wendell had a very interesting data point in one of his opening statements. When AI workloads, use cases become really effective, everybody talks about how much power is consumed in training. But boy, when that thing is deployed and inferred at the edge at scale, now you're talking power consumption, even more than the massive amounts that we're talking in the core data center. So I think, hopefully, I'm optimistic that sustainability is an overall theme, and smart, sustainable edge deployments specifically, because I think the edge is really going to take off.
Any other comments?
My prediction is that AI is really going to be the cause of a lot of the energy problems, but it can also be the solution to them. And I think there's like 3 areas that AI can really address things. So the first one is really the usage of AI. So think about if you're a trucking company or something, and you can do optimal route planning. which is a very difficult, it's an NP compute hard problem to do that. So, famously called the traveling salesman problem. Or, other uses of AI in industrial uses, as well as moving from large language models, which have a huge amount of parameters, to more focused, context-specific models that are medium and small language models that are specifically for the enterprise. So that's the first area. I think a second area that AI can have a huge impact on is in the data center itself. So, think about using AI to run the data center. So Google, in the Google DeepMind group, they actually applied a different type of AI, generative adversarial network, to try to optimize the power used by the data center against an objective function. And what they found is they could reduce power by 10x, which is just incredible. And the reason they could do that was that normal data center operators, only touch, they said, like 0.1% of all the settings and the cracks and the air conditioning and all of the heating and cooling equipment. Whereas using AI to look at all the permutations, they're able to come up with the more optimal settings. So that's the second one. And I think the third one is really in the equipment itself. We're able to make that more power efficient, as well as the data center operators really making the data centers more efficient itself with the lower PUE. So I think three kind of areas around power savings that AI can have a really big impact in.
Thank you. Kelley, you want to add
Yeah, I'll
some
just
things?
add a couple of comments. I think liquid cooling is here to stay, and as AI is pushing one of the trends in the data center, the edge is pushing it for edge deployments as well. And I think one of the other trends that we see as these workloads are evolving and companies are figuring out what's the most effective from an energy usage and from a cost perspective, what's the most effective way to carry out their workloads. I also think investments in green technologies like more solar, more trends in water, renewable energy sources, I think is going to be something that's going to continue to grow to help support the energy needed for these workloads.
Thank you so much. Okay, so we've got time for a couple questions. Go ahead. We're going to bring a mic to you so everybody can hear you.
We talk about liquid cooling and we talk about getting the heat out of the data center. How about if we come up with more responsible ways of actually doing something with that heat once it's outside of the data center? Having a cooling tower outside a building and just exhausting it into the atmosphere? Europe isn't going to allow that with new data centers going forward. So do you have ideas for that?
Absolutely. So this is a real great technology of immersive technologies that you can completely eliminate fans in the data center and you can almost have up to 100% heat recapture. And so Europe has actually the infrastructure built into their ecosystem that they can use district heating. The data centers are proximal to the urban locations and they can actually have the infrastructure already in place to heat buildings, to heat different areas within Europe. In the US and the Americas, some of the trends that we're seeing are to take that excess heat and use it for farming and bio usages. So like organic farming in areas where you may not necessarily have that. So these are some of the case studies that are happening today. What I will say though is that there's a lot of infrastructure that's needed to figure out how to repurpose and reuse this heat. And this is actually an ongoing work stream within the OCP community, is figuring out how to repurpose and reuse the heat for beneficial advantage.
We did a fascinating interview at OCP Lisbon earlier this year with a company called Carnot. They're out of France, and they did exactly what you asked about. They're heating local swimming pools with the energy taken out of a very modest-sized data center. It doesn't take much to be able to repatriate that heat for a second purpose. Well, maybe time for one more question. Do we have anybody else with a question?
I've seen a couple of smaller data centers where they're using like half racks or quarter racks because of power constraints in the rack and cooling constraints in the rack. Is there anything being done to, in the old days, data center space used to be a real problem, but then densities of disk drives and SSDs came along and pretty much eliminated that as an issue. Is there going to be like a cliff here with respect to power where different accelerators come on board, higher density drives, better cooling comes out, where the power requirements that we're seeing today, megawatt racks or higher, will no longer be a problem, will no longer need to be a problem? Is there a question there? Yes. I mean, so quarter racks is kind of interesting because, I mean, the hyperscalers obviously need, these huge scale racks, but enterprises aren't doing 1,000 GPU training clusters yet.
I mean, I think what we've seen is, I'm working with one of the companies that runs colo data centers, and they have a big initiative to enable what they call private AI for enterprise. So basically, you can lease a cage with a single rack in there, and it's already configured to be fully utilized. So every 42U of that is full of stuff. GPUs, storage, networking. They provide the power into it, which it's 50 to 70 kilowatts, depending on whether it's air or liquid cooled. So some of their data centers are liquid cooled, and they can get up to 70 kilowatts into the rack. And that's really kind of out of the range of what enterprises can do in their on-prem data centers. So I think that's for these high power workloads, it's going to have to move into a colo facility, something like that.
Is there any sort of optimization going on for smaller size racks? I see this huge racks on the floor, but I'm not sure everybody actually needs that. Colos, obviously. Hyperscalers, obviously. I mean, we're going from 60 terabytes to 122 terabytes, and there's no end in sight, as far as I can tell. So the capacity is going up considerably. The powers of the GPU with respect to, I don't know, inferences per watt or training items per watt is going up.
I think Ray is looking for a racklet design.
Yeah, so
Yeah.
I can speak to that. So at Iceotope, we have many different types of form factors that can leverage our technology. So we have, for customers that want to try out a proof of concept, we have a short half rack that is easily configurable to your needs, and it's not going to cost you an arm and a leg. If you're more interested in larger production workloads, we can accommodate that. So at least with our company and with our technology, we've considered those kinds of challenges and what the customer would need, and we can configure something that would be useful to that lower use case that maybe doesn't need 5 fully populated AI racks.
Thanks so much for the question, and thank you to the panelists. This was fantastic.